Hi, I'm Ng Sek Kai, pursuing Bachelor Science major in Physics in USM. This is JIM 319 Vector Calculus Individual Assignment. The topic of the video presentation is arc length and curvature of vector value functions. How do you apply it? And where do you apply the vector value functions? Let's go!
Hi, welcome back from the previous general formulation sections. Allow me to bring you into the nature and experience the growth path of a plant. Assuming the parameter equations of a spiral climbing plantations, there are three vector components. Component X, 3 cosine t. Component y equals to 3 sine t, and component z equals to half t. So let us further explore the use of the arc length functions and the curvature of the curve. As you can see, there are the trunk used to help the plants to climb in the spiral way. And the vector functions of the curve path that plantation growth is in spiral climbing growth path, given by rt equals to 3 cosine t vector I plus 3 sine t vector j plus half t vector k. And the times is 1 less than or equals to t less than or equals to 5. So I would like to find the arc length of the curve and the curvature of the vector's value functions. L equals to integrations of magnitude of r prime t dt from the t equals to 1 to t equals to 5. The given vector functions and r prime t is equals to negative sine t vector I plus 3 cosine t vector j plus half vector k. The magnitude of the r prime t equals to square root of the negative 3 sine t power of 2 plus 3 cosine t power of 2 plus 1 over 2 power of 2. The equation therefore equals to 9 sine square t plus 9 cos square t plus 1 over 4. As we since the sine square t plus cos square t, we can simplify it, factor it out, and we simplify it again from the factors, it will become square root of 9 plus 1 over 4. Eventually, you can find the magnitude of r prime t. So you just need to plug in the value of r prime t into the arc length equations. We got the integration of square root of 37 over 2 dt from t equals to 1 to t equals to 5. After integrations, it's equals to square roots of 37 over 2 times t from t equals to 1 to t equals to 5. And let us substitute the t values into the equations, and the final answer, you can see the arc length of the curve from t equals to 1 to t equals to 5 is equals to 12.165. If this is in value meter, means this one already grow 12.165 meter. What about the curvature? A kappa is representing the curvature. Curvature, and kappa is equal to magnetic tangent prime of vectors over magnetic of r prime. Let us find the tangent prime. As we know, the tangent t is equals to r prime t over the magnetic of r prime t. T equals to -3 sin t I plus 3 cosine t j plus half k over by square root of 37 over 2. Therefore, we can find the t prime from the t. Kappa is equals to the magnitude of tangent prime of the vector over magnitude of r prime, and equals to square root of -6 over square root of 37 cosine t power of 2 plus -6 over square root of 37 sin t power of 2 divided by square root of -3 sin t power of 2 plus 3 cosine t power of 2 plus 1 over 2 power of 2. After factorize, we know cosine t plus sine square t, cosine square t plus sine square t equals to 1. Hence, the kappa value is 12 over 37 in value, or equals to 0.324 growth rate. How fast is the growing rate?
As a conclusion, knowledge of applying the arc length and curvature of vector value function is so important and useful to every one of us. The application could be very wide, perhaps from your daily lifestyle to gigantic interstellar traveling and planetary orbital projections. I hope you enjoy the video. Thank you.